Alright, use the information diagram and proof to fill in the blanks given triangle ABC. Prove that a squared equals b squared plus c squared minus 2 times bc times cosine of a. So in triangle ABC, segment CD is drawn perpendicular to segment AB, therefore h is the height of triangle ABC. We want to show that a squared equals b squared plus c squared minus 2bc cosine of a. By definition of sine of A, the sine of A is equal to h divided by b. Again, because this angle, the opposite side length would be h, and the hypotenuse in that triangle would be b, so it would be opposite divided by hypotenuse. Therefore, using the multiplication property of equality, we have h equals b sine of A. Alright, so they just multiplied both sides by b right there to reduce that down to a 1 and solve for h. So also by definition, cosine of A is equal to s divided by b. Therefore, using the multiplication property of equality, we have s is equal to b cosine of A. Using the segment addition postulate, we can say that c is equal to s plus t. Alright, so the whole segment right here is equal to this segment plus this segment. Check. And t is equal to c minus s, follows from subtraction property of equality. So they just subtracted the s to both sides right there, and then had c minus s is equal to, and s minus s reduces down to that 0, and that's why they ended up with just t. So that's how they jumped from here to here. And then using the Pythagorean theorem in triangle CBD, we have, alright, so Pythagorean theorem is a squared plus b squared equals c squared, where c is the hypotenuse. So the hypotenuse is actually labeled little a, so it would be a squared is equal to the other two side lengths being squared. So that's h squared plus t squared. So they just used the Pythagorean theorem and the labels that were given on that triangle. So then they have, substituting for c, we have, alright, c in 4 right here, I believe. Substituting for, actually that ought to read t right there. We have a squared is equal to h squared plus, they substituted t right here being squared for the c minus s, so that ought to read t. Now we substitute for h and s. Okay, so this is the first blank. Well, what did h equal? And if we go back up through, we had h equals b sine of A. So in this first one, it's going to be b sine of A. So our first blank is b sine of A. And then plus c minus 2. Well, s, what did s equal right here? So we had s equals b cosine of A. So right here, they're going to write b cosine of A. So it'll be c minus b cosine of A. So that's our blank for 2, b cosine of A. And then it shows the work for how they simplified it. They factored out this b squared because it showed up right here and right here. So they gathered the sine squared of a squared and the cosine squared of a and moved them right there because they both were being multiplied by b squared. And then they moved this section just down right there. So then they had b squared times 1, and that is because sine squared of a plus cosine squared of a is equal to 1. That's the Pythagorean identity for trig functions. And then they just brought this down to right there. And then they had b squared times 1 is just b squared. So then they had b squared plus c squared minus 2bc cosine of a. And so that's how they stepped through the rest of that proof.